Okay, presenting blue goo. Okay, this is our formula. It is sodium carbonate and copper sulfate. Those are our reactants. We made a mix of sodium carbonate at a molarity of 5.3 grams for 50 milliliters, and we got that through this equation to find the molarity per 1,000 milliliters. And then we found the molarity of copper sulfate, and it came out to 7.975 for 50 milliliters.
This was found by taking the molar mass of each part of the compound here, then putting it over 1 mole and dividing by.
An aqueous solution is a solution in which the solvent is water, shown by AQ in a chemical formula. This is the molecular formula of our reaction of sodium carbonate and copper sulfate. This is the total ionic equation, which shows the charges of each of the compounds. And this is sodium sulfate and copper carbonate. And see, this is the only solid made in the reaction because they are not soluble after they've reacted. Spectator ions, they are ions that exist in the same form in both the reactant and product side. So here's the total ionic equation. And over here you can look at the net ionic equation. The net ionic equation, you can see that a lot of the compounds or elements have been removed from the equation because they are spectator ions and not important in the net ionic equation because they do not form a solid and therefore are not part of the reaction. They stay in an aqueous state and therefore are not part of the equation.
The net ionic compound shows the final product within the end of the reactants. So this is a solid that comes from the combination of all of these elements.
Okay, right now I'm measuring out a molar volume for 50 milliliters of water for sodium carbonate. So these are both molar solutions of sodium carbonate and copper sulfate.
What you doing, Anna?
I am mixing the 50 milliliters of sodium carbonate and I'm going to pour 50 milliliters of the other substance and then mix them. And now I'm going to poke it.
It's a goo. Sweet.
Okay, we're good.
Yay!